Welcome back, guys. This will be day 15 of me trying to learn TypeScript. Um, so today I'm going to be doing conditional types. Okay, I just finished revising generics now, and I'm just gonna get into conditional types. I might not do much because I might not finish. There's only 6 levels. I might not finish because I have to go study after this. So yes, I'm gonna do conditional types. I was like wondering when they were going to talk about the infer keyword. So it seems like today we're going to learn about infer. It's today, bro. It's today. I was scared of this day. Okay. So after that, I think what will be left to be how to install TypeScript using JavaScript library, using the module, or our TypeScript ignore, vanilla vite. The TS. This is very. This is this is what you call a complete course. This thing talked about everything, covered all of TypeScript. This thing did justice. It deserves for you to pay. Like I'll have to see, because for the other for the other courses I'm gonna take on boot.dev, like writing an HTTP client after this, I might have to pay, because this is just worth it. This thing, it explains very well. You get to do the exercises, and now I'm doing it on my local IDE, because on my local editor, because I'm not paying. I'm on guest mode. So for the like since I've seen that I can do this every day. Okay, I can do this every day, then I'm just gonna pay, because I can do this every day. I'm not gonna lose money. Because like the main reason why I did not pay is because I was thinking, what if I skip a few days? There's a test, we are attending, we're having projects. If I'm just skipping days without doing this thing, I will lose money. Because it's a monthly subscription. So if I like spend maybe 10 days in a month, so I lost. So now that I've seen I can like spend a few times doing this every day, I might pay. I might pay, because that's I thought it was like 200, 250. Then I might pay, because this is really worth it. You're like investing on yourself. Okay, so let me just get into conditional types. Conditional types. We're now getting into some pretty advanced stuff. While useful in really tricky modeling situation, it is not something you'll need in application level code. Thank God, bro. Thank God. Thank God I won't need this, but you have to learn it. Okay, as a general rule, advanced TypeScript features are more useful in library code that needs to be more flexible, abstract, and reusable. Application level TypeScript code is generally much simpler and more concrete. Grag make object type, grag use object type, grag AP. See, this is amazing. So, but we still have to do this. Because I might end up writing a library. I don't know. Okay, I might end up writing a small library that have been written before. Just check out they're doing it, and then try to write it the way I try to the way I understand what about. Okay, conditional types allow you to create new types based on condition within the type system. They take this form: so type, new type, some type extend, other type. If it does, we're returning true type or false type. Okay, if some type extend some type, return this type or this type. Okay, it reads like a ternary expression. If some type extend satisfies other type, then new type is new type, and then otherwise it's false type. Yeah, it's true type, otherwise it's false type. It's a simple example. Before, like, I go there, like, remember I said I've watched something on infer. I've like seen somebody teaching the infer keyword. So it was this guy. So like I really recommend you check out his video. Like, this guy, for learning TypeScript through video. Me, I'm not like I can't learn through video. I learn by reading and doing. But these guys' videos are very good. You should check them out. Okay, so this is a simple example. So a string, a generic type. Then if this type extend a string, return true. If it doesn't, return false. Usage type result 1. Then you can, this is a string, extend a string, meaning it's like a superset of string. It contains everything a string can contain. This was false. This is obviously true, because it will be just a string. In this example, a string is a conditional type that checks if a parameter t extends a string. If it does, the resultant type is true, otherwise it's false. TypeScript actually ships with some built-in conditional types. Type extract ut, t extend u equals t, then never, exclude, then this extends u. If it does, never, then if it, okay, non-nullable, t extends null, or undefined, we return never, or we'll just return the type as usual. The question is, when the heck is this useful? Well, let's say we have some event that can fire in our front-end application, in our front-end. Okay, so there's a click event, just an object to type click, and like x, y coordinates, whatever. Okay, so the key event, that mouse event, and then there's the form event, then events like union. It may be useful to dynamically create a type that only includes mouth events, the ones that have like, okay, click event, okay, mouse event, the one, okay. It may be useful to dynamically create a type that only includes mouse related events, the ones that have an xy property. We can use the extract conditional type to do so. Extract, there is, take two types, no, like it's a type, it's a generic type which checks if this type is a superset of u. If it is, we return the type. If it's not, never. Okay, so let's do this, then extract, and then we'll do that. Okay, and then here we just do type. Extract is a TS built-in type, and this is the implementation. Okay, so we'll pass in the type, and then to check if events is a superset of this. So the only one that will not get through here is submit, because it doesn't have x, y, and then key event won't get in. Click event and mouse event are the only two that will satisfy to be mouse related. Now mouse related is the same as, yes, so this is the resultant type. The difference is that it's dynamic. Okay, yes, it's dynamic. If we add more events to the event union mouse related, it will automatically include them if they match the condition. Yeah, okay, the difference is that it's dynamic. If we add more events to the event union, mouse related events will automatically include them if they match the condition. Yeah, if they have x and y properties. Yes, your assignment, support AI is experimenting with auto replies, but only for tickets that seem emotionally safe. Create and export a new a sentiment string utility type that that evaluates to made periods if t includes angry true and this otherwise. So let's still just do C types for conditional types. So there's nothing, so we'll export. We're exporting this sentiment string. Would check if includes that, so it will be this, and then we'll do the exclude. What's that built-in type? It's called extract. Okay, yeah, we're exporting a type, so we can call the extract. Let's see, extract. So we have a type. Yeah. So we have a type. Okay, this. Right. So here the type would be what are we doing here? Okay, if t includes angry true, then like, okay, value is to make true if true includes this. if t is a superset of this, if t is a superset of this, wait, let's see. You think you know the syntax, but you don't. Okay. Yeah. What's happening? So it will be this. Like it will be this, man. Like what's happening? Why can't it find t? Let's see. What's the issue, guys? I don't know, but it will fix itself. I'm not fixing it. So if t is a superset of this, and then return, okay, we're returning this. I think we're just gonna have to use that data values. Like we're creating our own type here. We're not using extract, right? Extract will just it will just return this type if it satisfies this, never otherwise. Yeah, we're creating our own type called sentiment string. That sentiment string, okay, our sentiment string should take in two types. That's what happens when you do something without thinking. So we're creating a new type called sentiment string. All type parameters are in use. Yes. Okay, it will check if t extends u. If it does, we return angry. If it does, we return angry warawara. And then if it doesn't, we return a string union, like whatever that is. We return this our type. Okay, so to use it, let's see. We'd create a type and then no, let's see. We'd create a type like this and pass in two types, right? And then let's see. We'd create a type like this and do add sentiment string and pass in the two types like this. And the other one would be just where is this coming from? Yeah, okay, we effed up, so we'll do this. Yeah, so like now the type, this type should be, let's see if it's in fed. Yeah, it should be content type. It should be like a string union, like a, yeah, to be like a this it can be content or AP. It can only be that. It's called string union using type analysis to create new types. Yeah, that's basically what they asked us to do. So like I spent a lot of time being stupid there and I wasted time. Okay, let's see. There's the infer keyword. Basically what it does, I think it checks if it's the type, if it's some type, like it does the same thing we did then, the conditional type. It just let's just read infer. The infer keyword, when used inside a conditional type, let us use the type of a value from the true branch. For example, okay, let's use the type of a value from the true branch. For example, we're creating a generic type. If type this t extends then this, like some sort of a function that takes in any sort of array, and then if infer r true, return r, never otherwise. Okay, I don't know what's going on here. Some sort of function. Okay, the get return type is a conditional G2 type that extracts the return of a function type t. Okay, yeah, that would be a function that takes in some array, some sort of array that has like a bunch of things, and then we infer r Okay, so we infer R. Okay, function T. Let's see. If we have a function great that returns hello world, I have no idea what the infer keyword is doing here. So it just checks in if what type is this? What is the type? And then returns the type, never otherwise. Okay, let's see. Function number returns the summation. That one greeting just returning. Okay, so greet return type, and then greet return type. Okay, we're getting greet return type. Okay, I get return type of greet. Oh, we're passing the type of greet. So the type of greet. What type of greet? What is greet? It's nothing called greet. It's just a method, right? Okay, the type of greet, like let's just say because it's returning a string, it's a string, and then if the string extends what? Oh my god, you might be wondering why is okay, yeah, instead of R, basically the why infer R instead of just R. Basically the TypeScript syntax says so. See, this is the type we're trying to match in the conditional because the returned value must be something. Okay, this is the condition we're trying to match because the returned value, this is the type we're trying to match in the conditional because the returned value can be anything. But why we can't use any because we're trying to capture the type in a type variable, so we use R. But TypeScript needs to know that R is a type variable. So that's what the infer keyword does. It says, hey, I made this new variable R. I want you to remember that in the conditional return statement, assuming the conditional is true. Okay, did you mean great return type? Okay, then the great return type will be this type here. Just learn what the infer keyword is doing. Okay, so great return type, we're passing in some type. What is great? Okay, great is a function that returns a string. So we're passing in a function that returns a, okay, so the type of greet will be a function, right? Yeah. The type of greet will be a function. So we're passing in function. If function extends, okay, if the type function, okay, extends a function that takes in some arguments. Okay, what would be the type of this? To be string, and then of this will be number. Because this is returning a string, this is returning a number. Let's just say if it extends, okay, extends some function. Okay, this extends you. If it does, return this as the type and then return this otherwise. Yeah, if it extends some function that returns in some value. Oh, okay, we get it. I'm not a genius. Took me time. Okay, it took me time, but we get it now. Damn. Okay, if T extends some function that takes in some argument, okay, and then returns some type R, infer that type. Remember that type, and then if T does extend some function that returns a type, that returns something of some type, return some type. If it doesn't, return never. So in a case where T won't be a function, what will be returned will be never. So like if we do type some type and do get return type, and then type type of just do okay, do this. Okay, it won't even allow us identify expected. Let's see. Okay, it won't even allow us it won't even allow us to do this. Identify expected here. Okay, let's see. Let's just pass in a type, man. Let's just pass in a type like this. This would be never, right? Yes, because t want t this function. Okay, now wait. Okay, so we're passing in function. If function extend some function, which it does in this case, because this is a function, this is a function. Yeah, like this condition won't be true if it extends a function. String, it's not some this is not a string, it's just some letters, right? Why doesn't it get like colors like a string would? Like a string would. Okay, if t, okay, in this case it will be function extend some function which has some return type. Remember that type and then return that type, otherwise return never. These are functions. Of course this condition will pass, and then just remember what the return type was, and then return that return type, else return never. So obviously this will be never, because it won't pass when you say, is this a function that has some return type? No, it is not. Okay, what if we do passing a function that does nothing? Okay, then the type will just be, okay, this function is returning an object, man. So if we do a function that returns that console logs, well, let's just do okay, no, nope. Okay, so it will be, let's see. Okay, console, why is it a capital here? Okay, it's not even allowing us to do this. Okay. Oh, can't we just create some simple arrow function now? Okay, let's just do const. So we let's just do an arrow function that console logs something. This function's return type is void, right? Yes. So let's pass in that function there. Okay, like we got an error there because we didn't do type of. We just passed in something. So we do type of, then we'll pass in fine. So yeah, it will be type void now. Okay, so yeah, we could have done it like this, then the beginning. Okay, this will be, let's see. Okay, so we can't do it like this. It doesn't allow us identify expected. Okay, the identifier of the function is expected. Okay, yeah, I get it. Okay, so we yeah. Okay, yeah. So yeah, it will be fine. Alright, yeah, we get it. Okay, the syntax. Come the syntax. Know the syntax. Okay, some function which has some return type. Remember that type. Return it and then never otherwise. Okay. Yeah, this was amazing. So what was the assignment? We didn't even do the assignment. Somebody is building a form preview tool. It lets developer generate mock inputs for internal functions. What does that even mean? Okay, Somebody is building a form preview tool. It lets developers generate mock inputs for internal functions, but first it needs to know what kind of input each function accepts. Yeah. Create and export a new generic input type. So I'll delete this. Okay, this will be and first and fair quiz. Fair quiz is not in type. So like would export some type. Okay, create and export a generic type. Okay, just do it. It's a generic type. Okay, the type does something. That extracts the type of the first parameter from a function type t. That extracts the type of the first parameter from a function of type t. The function can return anything. So here I guess would be no. Do we have to? Can we just say a function dot args, and then I think it was any. So with some, and then for r. Okay, that is some return type, whatever that means. Okay, we don't even have to know the intent type. We want like the first thing here. So would infer args. How do you say args? I can't do args. The first type here. How would you do that? How would you express the first thing in there? There's not even a hint. Need help? Oh my god. Okay, that take okay. Okay, extracts the type from the first parameter of a function of type t. Falls back to unknown if t is in a function. Okay, so we would have to still do t extends some function that is some return type, do something, and then else we return to unknown. I think is it unknown? I don't remember what they said. Okay, we're falling back to unknown if t is in a function or takes no parameters. So how do we know that it doesn't take any parameters? T extends y. Okay, see. It is a function, then return, does t extends x? Does t extends this? Return 1 if it does, 2 otherwise, and then the return extends the function. Whatever that is, man, I'm confused now. Okay, like I have an idea, but like okay, unknown otherwise. How do we know like it doesn't have any arguments? So we'll do we have to do some more checking, I think. Okay, see a function. Okay, time to GPT. I don't know what's going on. I don't know how to check for this. I don't know. We're learning from ChatGPT. Type and export from. Okay, GPT would be there. I want you guys to see my search history, so you already seen it. Hope there wasn't nothing weird in there. Or like how to fight a dragon, how to kill a Komodo dragon with my bands. Okay, let's just increase the thing so you can see. You're on the right track. Yeah, I know I'm on the right track, bro. I mean, okay, I'm not a genius, okay. Oh, yeah. We need to infer the type of the thing instead of just doing any. would need to infer the type the argument is taking. So we'd need to infer this. So what is the problem doing? Okay. Yeah, we would need to infer this. Okay, we're just gonna return a, let's see, what did ChatGPT say? ChatGPT gave me an answer and then I was like, okay, I don't care, I got it when I didn't get it. Okay, the function is returning anything, so that would be the return of the function. It's returning anything. Okay, like we don't care about the function's return. Okay, so we have to infer. Okay, yeah. The if, okay, yeah. Okay, so check. Okay, let's just see what you're on the right track, but the function isn't correctly extracting the first parameter type. Instead, it checks whether t is a function but returns an empty string, which is not what we want. Explanation: t extends args and it checks if t is a function with at least one parameter. If extracts the first type. If it's not a function but it's no parameter, it falls back to unknown. So like, how would we know that it doesn't have any parameters? Okay, no, okay. Unknown, this will be number. Okay, so this is a full, okay, it is at least, okay, yeah, this number is not a function. We're not even doing type of, and then type of bar doesn't have any parameter, so it will return unknown. Okay, thank you, GPT. So we want to infer the first argument. So like, and then we have to say like the function, but the function can take in additional stuff. I don't think we can use args twice. Args, and then do that. Okay, so yeah, we'll do, let's just do my type and then do input type of, and then we need to pass in type of number. This will be never, right? No, we won't pass in type of number. We just pass in like a type, and then this will be unknown because it's not a function. But if we add a function, say without, let's just do without first, which just console log something. Okay, the function broken spell function, should be arrested or something. Okay, let's just do type of my function. Then this will be a never to unknown too, because like it doesn't have anything. But if the function takes in something, even if it's just one thing, in its reserved keyword that is never used. Okay, like it will be string now. Okay, so like TypeScript, if the function is taking in something, would want you to use that thing. So we'll do, okay, in is like a special TypeScript keyword, so you can't use it as a variable. So yeah, this will be this. This is very, very interesting. Like I had no idea how to check if it is like the first argument. So or whatever. Okay, so if t extends a function which takes in one argument and potentially more, so like if you pass in a function here that doesn't take in an argument, it won't satisfy being a function that takes in one argument and infer the type of that argument. Okay, so like this is like what I was like thinking. Okay, like see, okay, this only t, it will satisfy if t, it will only, this type will only satisfy the this first condition if t is a function with at least one argument and or potentially more. Yes, this is what's up. Thank you, GPT. What's happening? Okay, programming, it's nice. Okay, maybe type, I think we're gonna end here today. Okay, just gonna end here today. We still have to go start this like maybe type. Remember dynamic properties. Yes, I think we do. It says this is a type that can take in any number of string number pairs. I think this is what it says, but this will not satisfy if it is okay. It's just another type. Okay. Well, mapped types are a way to create new types with dynamic properties based on existing types. For example, say we have a soldier type, okay, which is name, age, and branch, which is a union. Okay, and we want to create a new type that has the same properties, but all of them are optional. We can do that with mapped types. Okay. Well, map type are a way to create new types with dynamic properties based on existing types. For example, say we have a solid type and want to create a type that is the same properties, but all of them are optional. We can do that using a map type k in key of soldier. If question mark, then what? Okay, the key of operator gets the key of the soldier type. Okay, so we're trying to create a type that has the same properties. So we just check if k in key of soldier. So this will be the keys of that are in soldier. There will be name, age. So if this is in there, then I guess we're given a go ahead in. Iterate over them. Yeah, the keys of soldier. The question mark makes each property optional. The soldier key gets the value of each type. So here we just create okay, let's see. Okay, so like we would use utility types, man. What? Why would you do this? The obvious benefits, of course, is that we have an if we update soldier, optional soldier automatically updates too. Like, doesn't utility types does that too, changing the values. Map types are really useful for making properties optional or read-only, but it's an incredibly powerful and potentially dangerously confusing tool. You can also use them to change the value or the value type of properties. To change the value types of properties. So this will just be the value types of properties. Yeah, so then it will be the same keys here, but with string values, string values. So this will be this to be string values, which are the same as, like, why doesn't it tell us that utility types would have been better here? Why doesn't it say that? I want you to say it, man. I want you to say it. Okay, say that utility types would have been better for this, because I don't see myself doing this. What is this? Why would you want to make it string? In what condition would? Oh, but it did say that this is for libraries and stuff. Okay, the QA team at Support AI needs to reset from data to a clean state before each test you run. You've been asked to some generic type. It's not even generic type. It's just a type, bro. Use utility types. Okay, you've been asked to complete the blank type. It keeps all the optional. Yeah, it is a type. It is a type. So this will be key. Where's key coming from? It's a key though. It's a key. I keep going back and complaining. Complete the blank type. It keeps all the original keys of T, but forces them to be now. What? Okay. What? I'll complete all the optional keys of T, but forces them to be now. What? It keeps the original keys of T, but forces them to be now. Complete the reset. First, it accepts an object of type T and return a new object with the same keys and all values set to now. Does not mutate the original input object. To create a new empty object of type blank, see, would use this. Yeah, would use this, and then here it will be like an object that can take in any number of whatever. A type assertion is likely the easiest way. Yeah, I think I might need to do something like this in this situation. Okay, the code will be this side. So let's see. I don't know why I don't do this often. I think this is better. But after doing this, we can then do this. And this is better because you can see, right? Everything is like at the, I can like read and like see at the same time. So go back and forth. So blank is a type that does what? It keeps all original keys of T. It keeps the key but forces them to be null. Okay, so how do we like change them to be null, the type here? Because this is just saying it should be key from that, but it doesn't say anything about the type. Oh, because we're using generics. Okay, so it's just okay. Key of what? Wait, it keeps all original. It keeps all original keys of T, but forces them to be null. Okay, so would do now. I don't know what I'm doing, to be honest. Okay, the keys are first. It keeps all the original keys of T, but forces them to be null. I don't know what's happening. Confused again. Okay, complete the blank. It completes. Can you just do the function first? Takes in an object and returns a new object, and then the best way to create a new object is to say object as blank, right? A function whose declared type is neither undefined voice nor any must return a value. Yeah, and then we're gonna return results. But I don't know what we're doing here. This is where I'm confused. Okay, so we're saying what? No, what do we need? Need something here. Because I failed to solve this too. Today I was lazy. It's good to key in type of T. Oh. Yeah, whatever that is. I don't care about what is happening in the key. We'll say key of in type. In key of T. Let's see. What does the method do? What did the method do? Returns a new object with the same keys and value set to null. Does not meet the original input object. Yeah, the objective will be a type of class. So what are we doing? Results is it's an object of type s blank. And the const key inform object dot prototype has own property dot call form key. Man, what is going on here? Oh, what is going on there? I don't know what's going on there, to be honest. I'm just gonna end here. End the video. Okay, can't even. Then let's see. Yeah, they kept their types. So like, how do we change the types? So this is the way to change their types. Yo, I guess this is all. Maybe I'll get it in the revision because now I don't get it. That blank wara did nothing to. It did nothing to our object, to be honest. Absolutely nothing. I'd like to apologize for today's video being me just fighting GPT. I mean, that did say that it's advanced, so don't blame me. So yeah, tomorrow I have class later. If I wake up early, I might do revision and then finish off. And then after finishing off, because like this doesn't need its own day, come on, I might just do this. It will be the longest video ever because it will be the last of me learning. Then I'll spend a few days just revising, and when I come back after this week's test, when I come back, it's gonna be starting the project. It will be on a new playlist. So thank you for watching, and I'll see you on the next video. And these videos are just me learning, so I didn't claim to be a professional. I am a student. I'm struggling. Bye bye.